Oh, there you are. Okay. This is where I'm supposed to be. Sometimes I think I'm funnier than I probably am. Okay. Everybody, this is how we're going to do it today. I'm going to go through the lesson really quickly. And if we have time left over, I'm going to tell you exactly what to do. And so today, just want to start off by saying that you will not need your notebooks. You're going to have your notebooks with you. So do not give them to Miss Kelly today. Am I clear on that? Do not give your notebooks to Miss Kelly today. Everybody keep your notebooks, all right? So we're going to go ahead and get started. Everybody crack it open, get that book open to, can't see the page, 139. Okay? Page 139. I'll give you a minute. I'm going to readjust myself. Oh, I'm getting old. Okay. Okay, here we go. Okay. Page 139. We're going to start talking about chemical changes. I'm going to read the first paragraph and then we're going to go from there. Okay? So everybody look on page 139, top paragraph. Now that we've talked about physical changes, we need to study chemical changes. Remember that chemical changes occur when the molecules in the substance change their chemical makeup. For example, most of you have seen natural gas on a stove or in a furnace. It's a pretty blue flame that can be used to cook food or heat a home. In order to make that flame, natural gas is burned. The main component of natural gas is methane, and it's a chemical formulation CH4. Remember carbon, and then there's 4 hydrogen. Thus, a molecule of methane is one carbon one carbon atom linked to 4 hydrogen atoms. When methane burns, the oxygen in the air interacts with the methane molecules, changing them into water and carbon dioxide molecules, thus resulting in energy being released, which we detect as heat and light. Okay, let me just say that the hard part about me doing this is that you can't ask questions. It's actually a lot easier for me. But you can't ask questions, so if you don't understand, I will email this to you, this video. I'll send it to you, or I'll send you the link. You can watch on YouTube. And when you do that, you can go back over and see if you catch on this time, okay? So that's what I want to let you know. If you don't get it in class, feel free to go back and watch it again, and I'll send you the link to where you can watch it at home. Now, if we wanted to write out the chemical change that occurs when methane burns, we could do so like methane and oxygen interact to make water and carbon dioxide. Or you could just write it in its little abbreviated letters. We'll use the chemical formulas and we'll replace it. So let's say we'll use chemical formulas of the substance in the reaction instead of their names. We'll replace "and" with a plus sign, okay? And we'll replace "interact to make" with arrows. So CH4 plus O2, O2 is oxygen, interacts to make H2O, which is water, and CO2, which is carbon dioxide. So we've got CH4, which is carbon and hydrogen, plus O2, which is oxygen, and it turns into water and carbon dioxide. Now, it turns out that if we were able to watch this happen on a molecular level, we would see that it takes 2 oxygen molecules to interact with 1 methane molecule, and the result is 2 water molecules and 1 carbon dioxide. So really, to abbreviate what happens, we need to add this, CH4 plus 2 H2Os equals, plus 2 oxygens, then interact to make 2 water molecules plus CO2. All right? Okay, so let's see, a couple of paragraphs down. What we did was put numbers, I gotta prop my book up. What we did was put numbers to the left of the chemical formula. These numbers indicate how many of each molecule it took to make the chemical change. This is called a balanced chemical equation. The chemical equation occurs, the chemical equation that occurs often is called a chemical reaction. Now, we could say that this is a balanced equation above describes the chemical reaction that takes place. And it does. Like I was saying, if you mix the methane and the oxygen, it creates water and carbon dioxide. So it is a chemical reaction, those things coming together to create these other molecules. It's important for you to understand that when a chemical reaction occurs, the molecules on the left side of the arrow are destroyed. Remember, it's not a physical reaction. You can't get those things back. It's chemical reaction. Oh my gosh. I saw this on my shirt and I thought I had spilled food on me. I've lost it tonight. It is 11:30 on Friday night, so I'm really tired. So I'm going to kind of booger through this lesson. I tried to get it done earlier today, but it was not happening. So let's see here. Thus, in the burning of methane, we are in the next to last paragraph on page 139. In the burning of methane, we start out with 1 methane molecule, CH4, and 2 oxygen molecules, O2. These molecules interact, exchanging atoms so that the methane and oxygen molecules are destroyed. In the process, 2 water molecules, H2O and 1 carbon dioxide, are made. In chemical terminology, we call the molecules on the left hand of the arrow reactants because they react with one another. Trying to fix my bridges. The molecules on the right side of the arrows are called the products. Now, you need to remember that the subscripted numbers refer to how many atoms there are. Okay, it's not the number of molecules, it's the number of atoms. Let's flip on over here. Let's look at the on your owns. Y'all want to go over those? Okay. 511. On page 140. One of the main chemical reactions used to run an automobile engine is the combustion of octane. So, octane is C8H18. Now let's take a look here. 2 C8H18 plus 25 O2s. So that's 25 oxygen molecules. Interact to make 16 carbon dioxides and 18 H2Os. So let's look at A, B, C, and D there, okay? Because that's your answers. Write the chemical formula for the reactants of this equation. So the reactants are what's on the beginning side of the arrow. That would be C8H18 and 25 O2. Then write the chemical formula of the product of this equation. Remember, like when you're doing math, a product is the answer of a multiplication table. Well, this kind of looks like a multiplication problem, but it's really not. So Let's remember that and remember that the product is the answer. Okay, so it's the stuff that comes out at the end. The chemical formula of this product is CO2 plus H2O. All right. How many molecules of C8H18 are used in this reaction? C8 and H18. How many molecules? Did you say 2? Are you sure? Well, you're right. So, there are 2. How many molecules of H2O are made in this reaction? Not used, but made. H2O. 18. Very good. Okay. Now that we know how this works, making this chemical reaction, meaning that you've got one thing and then it changes into something else after there's a chemical interaction. Let's look at photosynthesis. Okay? So, as you already learned, this process converts carbon dioxide and water into oxygen and a simple sugar called glucose. The balanced chemical equation is, this is the chemical equation, okay, because you remember we've got to turn carbon dioxide and water into food, okay? So here we go. 6 CO2 plus 6 H2Os changes into, interacts to make glucose, which is C6H12 and O6 plus 6 oxygen molecules. All right? So the C6H12O6, that is glucose. That's the formula for glucose. So when you take the carbon dioxide and the water and put them together, it turns into glucose. Now, I will tell you that it takes some energy to do that. And when it does that, where do these things that make this that make this simple sugars through photosynthesis, which means it's a what? Do you know, Jack? He's not listening to me. If something goes through photosynthesis, what is it? It's a plant. That's what he said. He said it was a plant. So it's a plant. So if it's a plant, it's making its own food here, so it's autotrophic. So, man, I look awful on this thing. I can't not think about it. I'm looking at myself. I hate this. I don't know how y'all look at me every day. He's getting ready to go to bed. He's talking all sassy. Okay. Sassy. He's sassy. Okay. I'm gonna stop looking at myself. I'm gonna put like something crazy on there, like that. Hide my face. About one of these things. Pardon me. There it is. I'll put one of these things.
Oh Lord, what's really bad is I don't know how to get it off.
That is hilarious. Okay, oh, there it went. Oh, it's late and I'm tired. So let's continue our lesson. Okay, for reals. So, photosynthesis is, you got your autotrophs, they're making their own food, and in order to get their food, they've got to turn this water and carbon dioxide into some glucose, which is like a sugar. So, we got to do that, and it's also got to make oxygen, because remember that's what it puts out into the world so that we can use it and give it back its carbon dioxide. Now, the problem with this is it takes a really long time for those chemicals to have that reaction and convert to sugar. And the problem here is, I mean, it would be fine if it took a long time on a normal basis, but that plant, I'm sure, is pretty hungry and it's wanting something to eat. So why don't we just give our plant something to eat? Well, so it doesn't happen like that. Remember, it makes its own food. So what it needs is this thing called a catalyst. Look on page 141. A catalyst is a substance that alters the speed of a chemical reaction, but it's not used up in the process. Ugh, now I got the hiccups. How cool is that? That's really cool. So, most catalysts speed up a chemical reaction, but there are a few that are known to slow it down. But typically, catalyst is something that speeds up the chemical reaction to further the process quicker, okay? So, an autotrophic organism needs something to speed up the photosynthesis. Well, what do you think the catalyst in this would be? I really hope that Cash did not say chloroform this time, because that's creepy. So, no, it's not chloroform, it's chlorophyll. So, let's look on paragraph 4 on page 141. Second sentence. Most autotrophic organisms use photosynthesis to create their own food. This process is a chemical change that takes 6 carbon dioxide molecules and 6 water to make 1 glucose molecule and 6 oxygen molecules. The glucose is food for the organism, and the oxygen goes back into the atmosphere. But in order to do that, the chemical reaction must occur. However, the organism needs more than just carbon dioxide and water. It needs energy. The energy source for things that have autotrophs that live through photosynthesis is the sun. So that's pretty exciting. It gets its energy from the sun. Now, let's see, bottom paragraph, about halfway through. God has designed his creation so intricately that even a single-celled organism like the euglena knows how to feed itself by collecting carbon dioxide and water, producing a catalyst that will speed up its own reaction, trapping energy from the sun to make a reaction occur. If it hasn't already become clear to you, this should drive the fundamental point that there is no such thing as a simple life form. That is pretty stinking amazing. Okay, turn the page. Bing! Did y'all ever have those when you were little? You know, those little like books, and it would have an audio with it, and it would say, turn the page. Bing! And now you just have me. I'm so sorry. Okay. Let's look on page 142. Now we're going to talk about organic chemistry. Now, let me look up this page because we studied something last time. I'm going to mark my page there. Organic molecules, most important chemicals in the study of life, fall into a broad category called organic molecules. Now, organic molecules, remember the test this time is definitions. It's all vocabulary. So if you see one of these, you might want to know that. It's a molecule that contains only carbon and any of the following: hydrogen, oxygen, nitrogen, sulfur, and phosphorus. Now, turn the page back really quickly. Keep your thumb in this one. Turn the page back to 129. What do we see there? Remember that biological table of important elements to know? Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Let's look back on page 142. On 142. An organic molecule is a molecule that contains only carbon and any of the following:
hydrogen, oxygen, nitrogen, sulfur, and phosphorus. I told y'all it's really late. I have to try to do something to keep myself awake because I'm tired. So, organic molecules. If you all remember that stuff that was on page 129, same thing here, okay? Now, when a living organism takes small molecules and makes larger molecules, it's called biosynthesis. Remember, bio means life. So, synthesis means a production. So, biosynthesis is life producing. So, let's look at the definition. The process by which a living organism produces larger molecules from smaller ones. Well, that doesn't sound too difficult, does it? Biosynthesis is the process by which living organisms produce larger ones from smaller ones. Okay, it produces life. It keeps going in a reproduction of what it is. So now, let's skip down and look at carbohydrates. Carbohydrates, I'm trying to hold my page open. Carbohydrates are organic molecules that contain only carbon, hydrogen, and oxygen. They have the same ratio of hydrogen atoms to oxygen atoms as does water, meaning hydrogen for water is H2 and O. So it has the same ratio. So it's going to have twice as many hydrogen as it does oxygen. Okay? Oxygen atoms. So let's take a look at that. For example, one of the simplest carbs is glucose. Glucose is C6H12O6. 12 is twice as much as the 6 in the oxygen. So you're going to have twice as much because it's H2O, twice as much hydrogen as you do oxygen. So it's C6, that's 6 carbon atoms, H12, that's 12 hydrogen atoms, and 6 oxygen. All right? So, let's look at the term carbohydrate real quick. Carb stands for carbon. Hydrate means water. Well, look at it. Carbon and water, that's what this is. So, when it says hydrate, it means to add water. It stands for the fact that there are twice as many hydrogen atoms, blah, blah, just like water. All right. Now we're going to look at the structural formula, but we're going to do it very, very quickly because it's not one of the points that I really think is necessary to bring out in this lesson right now. Okay? Let's look on page 143. And this is exactly what was written just a minute ago. That's C6H12O6. That's what we're looking at here. If you counted all of them up, you would see that it equals out. Count up all the H's, you should have 12. You should have 6 C's, and you should have 6 O's. Okay, now, this is called their structural formula. It's what they look like. It's just a picture of what the molecule looks like, how the atoms are arranged in order to make it what it is. Let's look at the one on the bottom there. See how it's arranged differently than the one on the top? Okay, turning the page. Not surprisingly, the first structural formula of glucose is called a chain structure, while this one is called the ring structure. The first one that was up at the top looks like a chain. This one looks more like a ring, okay? When two different molecules have the same chemical formula, they're called isomers. Now remember, your chemical formula can look the same. Let's look down here at the bottom. C6H12O6. We're on page 144 and looking at figure 5.3. See how you have the chain structure on the very bottom, the ones that look like a straight line, and then the ring structures. Pardon me. But if you'll notice, that's glucose and fructose. Those are two different kinds of sugars. But they still have the same formula, that C6H12. They have the same numbers, but they're structured different, and that's how you tell them apart. Now, page 145. Glucose and fructose belong to a class of compounds known as monosaccharides. Now, if you have ever read a label for food, or you have ever read a book on health, or you have ever heard somebody talk about improving your diet, a healthy diet, then you have heard these next few words, as well as carb, which we talked about a minute ago. Monosaccharides, that's also one of your vocabulary words. So, monosaccharides are simple sugar. Mono means one, okay? Let's remember that. Mono is simple. Simple carbohydrates that contain 3 to 5 carbon atoms. Monosaccharides. Let's look at mono and simple. Let's try to connect those two so that we can easily determine which one is a monosaccharide. Monosaccharide has simple carbohydrates that contain 3 to 10 carbon. Now, disaccharide, di means what? Do you know, Jack?
But not with it.
Ugh. He pains me. He said that die means to not live. Well, okay. Die means two. Let's remember that die means two.
That means two.
That's right, Jack. Die means two. Let's remember that die means two. And when we remember that di means two, we'll be able to figure out the definition, because the definition is the carbohydrates that are made up of two monosaccharides, so two simple sugars. Then you have polysaccharides. Does anybody know what poly means? You can answer even though I'm not here. Did somebody say it? Do you know what poly means? Many. I got it right. So, poly means more, many, okay? So, the definition is polysaccharides are carbohydrates that make up more than two. So, if disaccharides are two, poly's more than two, and mono is one, we got this figured out. We can find that we can clearly distinguish those when we're trying to do our vocabulary test. So, table sugar is a disaccharide, which is sucrose. It is formed when glucose and fructose chemically react in a process known as dehydration reaction. So, if it's a dehydration reaction, what are we getting rid of? When something dehydrates, what do? Do you soak it in water? No. When something dehydrates, you take the water out of it. And so that's what happens here. Remember, when for dehydration reaction, you're looking at removing water. Those are your keywords. A chemical reaction in which molecules combine by removing water. Makes sense to me. Okay. Now, let's flip over to page 146. People and animals make their own starches, okay? Those are called glycogen, and glycogen is produced. It's a sugar that is produced, a starchy sugar that is produced when you have too many carbs. And what happens is your body produces this glycogen, and it's like, okay, it's kind of, okay, your body produces glycogen. If you have too many carbs and you produce too much glycogen, your body decides to hang on to that and use it for later. The problem is most people don't use it for later. They don't use the energy that it takes to burn it off, and so that glycogen turns to fat. So if you've got little love pouches on your sides or on your arms or your legs, it's because you're not burning enough of the glycogen. You take in too many carbs, you take in too much food that converts to sugar. And so that sugar then converts to fat. Now, we're going to talk about the non-digestible part of your food. It's called roughage, and it's made up of polysaccharides known as cellulose. Now, most organisms cannot digest cellulose. God has created a few protozoa, bacteria, and fungi that they do feed on that, and most of those help break down other cell walls so they can consume it. But what's really kind of cool is our bodies do not digest cellulose. So that's why when you eat a lot of green, leafy, like this, the cell wall is made of cellulose. When you eat a lot of green leafy things, your body doesn't digest it, and the cellulose is not broken down for energy, so it's called roughage. It moves through your body quickly, and it kind of cleans out your stomach, your small intestines, your large intestines, colon, and your whole bowel system. So that's what we call roughage, and it moves through that system pretty well. Carbohydrates are one of the principal sources of energy for most animals. So it is what we live off of, carbohydrates. But like I said before, if you have too many carbohydrates, then your body does not use all that energy. If you don't use all the energy, it stores as glycogen, and glycogen turns to fat. Now, let's look at the definition on page 146. It's hydrolysis. The process to where water is added to create a chemical compound, a chemical reaction, that's hydrolysis. Let's look at the definition. Breaking down complex molecules by the chemical addition of water. Jack's going to bed. You want to say night-night? You'll say night-night, baby. You'll say night-night, baby. Oh, he says night-night. Okay. So, let's look at page 146. Organic acids and bases. Basically, I'm just going to quickly go over this because you don't have any vocabulary in this area. I just want you to know the difference between things that are acidic and things that are alkaline. Two classes of molecules that you'll need to learn in chemistry. You're going to learn all about it in chemistry. That's why I'm not going to cover it that much here, because it's not as important as to what we're doing. But it's part of the chemistry of life, so I have to cover it in this section. Acids and bases. Everybody really quickly skim over to page 147 and let's look at figure 5-6. Now, figure 5-6 goes from 0 to 14. All right? Now, my knees cramped up. Okay. So, let's look at our little scale here. 0 is about as acidic as it can possibly be. Okay? Battery acid falls in the line. I think battery acid something like 0.06, something like that. It's one of the most acidic things there is. Lemon juice is a 2, almost a 3. Vinegar is in the 3s. Orange juice is in the 3s. Then as you move up, you'll see tomato juice. Tomato juice is very acidic. Natural rainwater. Well, because of pollution, there's all kinds of acids that are in natural rainwater. Pure water, purified water, the water like you end up getting through the faucet, is a 7. Milk is probably about 6 point, trying to think, it's something like 6.25,
6.4. Blood, the range for pH for a person's blood is 6.45 to 7.45. So, I mean, there's a really small window there. It's just literally 1 point that it has to fall between, or you have too much acid in your blood, or you have too much alkaline in your blood. And I've seen both while working in the hospital with patients, and it's pretty bad. I've seen patients that their blood even starts to smell like ammonia, which leads us down the alkaline area. Household ammonia, like what you have under your sink at home, some people don't even buy it anymore as a cleaning product because it's so alkaline that it'll burn. It's a good cleaning product though. So household ammonia is a 12 and lye is a 14. And I don't know if y'all remember, if y'all have been to any of those, like at Dollywood even, they make lye soap. It's a very a very alkaline soap, but lye will burn you. So you gotta be real careful. That's my husband and I were talking about it earlier this evening when we were saying that it's two extremes. They are both very extreme, all the way from battery acid to lye. And they can both burn you, but one has an acid base and one has an alkaline base. So let's see. Let's look at the on your owns here. 516, which solution is the most alkaline? Lye. Which solution is the most acidic on this scale? Battery acid. Good. Okay. Now we're going to talk just for a minute about lipids. Lipid is another word for fat. That's just how it is. Lipids are also known as fats. They're complex molecules that form when three fatty acids come together. Let's see, I can't read my own writing on my page here. In general, lipids cannot be dissolved in water. Cooking oil, for example, is made of lipids. What happens when you try to cook water and oil? They do not mix. This is because the structure of the components of lipid molecules make them hydrophobic. Hydro means what? Did you say water? Hydro means water. And phobic means off-put. Scared. People sometimes say phobic is a fear. Well, this is not really afraid of water, but it's lacking an affinity for water. That means it doesn't go together. They don't mix well. Okay? So hydrophobic means lacking an affinity for water. That is one of your vocabulary words. Let's see. On page 149, nowadays nutritionists also tell us that saturated fats tend to lead to heart troubles, while unsaturated fats do not. As a result, they suggest that we eat unsaturated fats. What's the difference? When a fat is made from fatty acids to have no double bond between the carbons, it forms a saturated fat. We call the fat saturated because it has all of the hydrogen that it can take. It's saturated with hydrogens. That's as many as this molecule can hold. As a result, it's saturated. If a fatty acid has one or more double bonds between the carbons, it has fewer hydrogens than it possibly could. As a result, it's called unsaturated. So, saturated fat is one of your vocabulary. It's a lipid made from fatty acids that have no double bonds. Unsaturated fat is a lipid made from fatty acid that has at least one double bond. Okay? Now, let me adjust this again. So, excuse me. Let's look on page 149 at the bottom in proteins and enzymes. I'm not going to go into a lot of stuff here. Proteins make up one of the most important groups of molecules in the chemistry of life. The basic building blocks for proteins are amino acids.
You're going to learn a little bit about that in this section. Amino acids link up using dehydration reactions. Remember, once the water is pulled out of it, it's able to make that chemical reaction, just like monosaccharides do when they link up to form polysaccharides. As the amino acids link together, ejecting water, it bonds, and it's called a peptide bond when it forms. Now, peptide bonds, we're on page 150 top. This is a vocabulary word. A bond, so that's going to be your keyword to remember in the definition. It's a bond that links amino acids together in a protein. Peptide bond. Enzymes are something different. They're a special class of proteins that act as catalysts for many of the chemical reactions that support life. My computer's doing something funky. Normally at this time of night it'll restart, and so I don't want it to do that, so I'm trying to keep it from doing that. Okay, so enzymes are the protein that acts as a catalyst. Let's see, let's skip over, you're not going to do experiment 5.3. Do not do it. We're going to look really quickly on page 154 and 155, okay? 154, on figure 510, there is a picture of a strand of DNA. We're going to talk about DNA in great lengths on module 7, which will probably be the last module right before Christmas. So we will get to that this semester, but I'm just going to give you a couple little clues into how that goes. So let's take a look at it real quick, okay? On page 155, we're going to give you a little glimpse into DNA so that maybe you can better understand it when we start studying it, okay? Deoxyribonucleic acid is DNA. It's a double chain of chemical units known as nucleotides. These two chains twist around each other in a double helix that is so familiar to most people who have studied this in biology. I think just about everybody is familiar with the double helix of a DNA. The nucleotides that make up these two chains are composed of 3 basic constituents. Deoxyribose, we're on page 155, top paragraph. Deoxyribose, it's a simple sugar that contains 5 carbons. A phosphate group, it's an arrangement of phosphorus, hydrogen, and oxygen atoms. And a nucleotide base. Now, remember that the nucleotides are the double chain. All right? A nucleotide base can be one of 4 different types. I want you to try, we're going to go back to these, like I said, in great detail whenever we do our module 7. We talk about DNA and RNA. But right now, the 4 things that you're going to need to remember are adenine, thymine, guanine, and cytosine. Those are the 4 trying to put it in English. Those are the 4 chemical structures that form and determine DNA. In the lower part of the left-hand side of the figure, you can see that the phosphate groups link the deoxyribose units, which support the base. The 2 nucleotide chains are held together because the bases link together in a process known as hydrogen bonding. Hydrogen bonding is one of your vocabulary words. A strong attraction between hydrogen atoms and certain other atoms, usually oxygen or nitrogen, in specific molecules. Okay? So, excuse me. It's like 12:05. I'm tired. Okay. Now, that is a 45-minute lesson that in class probably would have taken me an hour and 20 minutes. So, let's do this. This is very, very important. Oh, I don't have it with me. Yes, I do. Hang on just a second. Well, I knew how to get in this backpack. Life would be easier. Golly gee. Ha. Here we go. Okay. Your notebook. This is what I want you to do. The reason that I didn't want Miss Kelly to grade your stuff today is because you're going to be working in your notebook for the rest of the class period. What that means is next time we have class on the 24th, there is going to be a lot of work that she's going to have to grade. So I want you to be gracious in allowing her time to do that. And we'll need to help her out. It may take a couple weeks for us to get caught up. If I were there, she could grade all of your work and have it put in the system, but it may be 2-3 weeks before we get everything caught up and put in its place where it's supposed to be. So like I said, show some grace, and I'll send your parents an email and let them know that this is how it is, okay? So let's see. What I want you to do is turn in your notebooks to page 117, the optional summary of Module 5. What that looks like is a bunch of fill in the blank questions. These are in order in your book. They are in order, okay? I want to make this really clear. These are in order in your book. So right now, I want you to get out your pens or pencils preferably so that you can erase if you mess up. I want you to go to page 117, and for the rest of class time, I want you to do page 117, 118, 119, 120, and 121, and 122. That is a lot of work, and that's what I want you to do for the rest of the class time. You should have your book. You should have your notebook. Don't work with your neighbor. Just sit there and do this work by yourself. I don't mind if you need a little space to scoot out from your partner just a little bit. That's fine. There is very little conversation here. There shouldn't be any questions because all of these questions, all the answers are in the book right in front of you in order. So all you have to do is open your book and start reading, and as you read, you can go through this. Some of it's a review from last week, but make sure, page 117, optional summary of Module 5, Module 5. Go from page 117 to page 122. If you finish this work, go ahead. Like if you finish this and there's still time in class, go ahead and go back to page, Jack's already done his, go to page 100 and 101 and write in the vocabulary words for this time. Go ahead and start on your homework, okay? So, if you finish that, then go to Module 5 on your own. All right? And start doing the on your own. You should have half of them already completed. And now, you can finish the ones that you didn't complete. You will take a test home with you. So Miss Kelly will give you a copy of the test. It's all vocabulary. You should take it. So here's your homework. In class, work on the module summary. Got it? In class, work on the module summary. If you do not finish the module summary, don't worry about it. Do not do it at home. It's just busy work. Don't do it. Do the rest of your vocabulary for this section of the module that we just covered. Do your on your own, because that'll count on your score. Do the on your own and the vocabulary for the information we covered today. Skip the experiment in this section. I think it's 5.3. Skip that, okay? And do the test. The test will be due next Monday with all of that work, and we will check the remainder of Module 3 and Module 5's on your own and vocabulary. And don't forget, next week, I need, if you want your extra credit for those 2 labs, then you need to turn that in next week. Miss Kelly will not take it today because she's not going to grade that. I'm going to grade that. So, if you have any questions, text me, email me. I wouldn't say call me today. Don't call me today. My little girl's having surgery and we have to be at the hospital at 6:45 in the morning. And so I'm going to sleep. So if she's sleeping, I'm sleeping. So anyway, if you have any questions, let me know. I'm here to help. I'll do whatever you need. But just maybe wait till tomorrow or so before you do that. I will copy this video to everyone's email, so that way if you need to see it and you need to go back and recheck some of the work or the things that I said, or you're not clear on your assignment, then you can go ahead and check that. Otherwise, go ahead right now and go ahead and start on that Module 2 summary. Module 5. God, I'm hung up on 2. Start the Module 5 summary. Do that for the rest of class. If you get rowdy, then we're going to close it down and Miss Kelly's going to have to pull you out, because this is something I really need y'all to behave when I'm not there, okay? So I'm going to send everybody's mom and dad a little email reminding them I'm not going to be there. But you know your homework. You know the work that's due next Monday, and I will be back. So if y'all need me, let me know. And if not, I'll see you next week. Enjoy your week. See ya.